You know, one way to solve very special, somewhat simple quadratic equations is to actually use the square root that we know. And we've got to be a little bit careful here because remember, when we take a square root when we're solving a quadratic, we have to remember to take both the positive and the negative square root. Basically, as sort of a general way of thinking about things, if we see a quadratic, we should be thinking of expecting two answers. So let's take a look at an example. X squared equals 25. There's an equation. And what I'd like us to do is solve that, not by factoring, but by taking the square root of both sides. So when I take the positive and negative square root of both sides, I see x equals plus or minus, well, the square root of 25 is 5. So this actually is a shorthand way of saying two answers. X equals negative 5, x equals 5. And so now, what do? Well, I can check the answer. I can put in negative 5. Negative 5 squared is 25. That checks. Put in 5 squared, 25. That checks. So we're in good shape. Let's try another example. All right. So let's see. I've got x squared equals negative 9. So I want to take the square root of both sides, but I've got some trouble because I cannot take the square root of negative 9. That is not a real number. And so the problem here is that if you think about it, when I take a real number and square it, if the number is 0, then 0 squared is 0. And if the number is anything except 0, I take that real number and I square it, I get a positive number. So never will the square of a real number be negative 9. There are no solutions to this. And so while you'd want to take plus or minus square roots of both sides, you can. But once you take the square root of negative 9, you have left the world of real numbers into some imaginary world which we're not even thinking about. So we are actually going to say this has no solutions. Using the square root idea as a means of solving simple quadratic equations is sort of handy. Let's take a look at this one. 9x squared minus 49 equals 0. And I want us to solve this using the square root function. Well, the way to do this is to just try to isolate the x squared. So first let me add 49 to both sides. So I'll have 9x squared equals 49. And then I'll divide both sides by 9 to undo the multiplication by 9. And what I see is x squared equals 49 over 9. And now, when I take the square root of both sides, on the right I see positive or negative, the square root of 49 over 9. And what does that equal? Well, that equals positive, negative. The square root of 49 is 7. The square root of 9 is 3. So I see two answers. X equals 7/3 and x equals negative 7/3. And we can actually substitute back to check. Let's just do this sort of really quickly here to sort of see that this seems okay. So a little check. A little check is always a good thing to do. When I put in, let's try the negative 7/3. So 9 times negative 7/3 squared minus 49. Well, negative 7/3 squared is going to be 49 over 3. And I get a little bit of cancellation here. 49 over 9, because I have to square 3 too. And I get a little bit of cancellation. And I see 49 minus 49 equals 0. It checks. And what about if I plug in a positive 7/3? Well, then everything else checks as well. It's the exact same once I put a positive sign there, because 7/3 squared is 49 over 9. Checks.
Okay, so as you saw in the Dr. Berger video, if you have a quadratic equation in this form, where you have x squared is just equal to some constant term, you can use the square roots property to solve it. Now the square roots property says you can take the square root of both sides of an equation and the two sides are equal. So for this opening example here, you have x squared is equal to 36. that means you could square root the x squared, which then cancels out the squared and leaves you with just x. And you could square root the 36, which, because 36 is a perfect square, would give you a plus or minus 6. So both positive 6 and negative 6 would work here. Now, a lot of times your quadratic equations will be in a form that might look like this. And so far what we've been doing is, if we wanted to solve a quadratic, we would try to get everything on the same side and 0 on the other, and that's why we called it finding the zeros. But this time, because there is no x term,
right, let's take a look at this one. 0 equals negative 3x squared plus 60. So the way to solve this is maybe to add 3x squared to both sides. And so I see 3x squared on the left equals just 60 now on the right. Divide both sides by 3 to undo the multiplication by 3. And I see x squared equals, and this becomes just 20. And so x equals, and now I take positive or negative, the square root of 20. And what does that equal? Well, I could simplify that a little bit because I can see that 20 actually is 4 multiplied by 5. And so this simplifies to positive or negative 2 square root of 5. And if you want to look at that numerically, we can actually plug that into a calculator and see that numerically we're talking about approximately a positive negative 4.47. And we can actually graph this and check it on a graphing calculator. And if we take a graphing calculator and check, we can actually look at the graph of y equals negative 3x squared plus 60 and see where it crosses the axes. So you can look at that picture there and you can see that it seems to cross around 4.47 and negative 4.47. Or you could actually plug these values in to this and actually see that we get numbers that are essentially 0. So you can actually check using a calculator if you wanted to. All right, let's take a look at a real-world application where we can see these ideas growing out of the ground. So a nursery manager is buying fencing to enclose 3 sides of a garden, the 2 short sides and 1 long sides. And one of the long sides. Now let's just take a look and see what we've got going on here. So here's the situation. So we've got sort of a brick wall here, and then we've got this garden set up, and you can see the really pretty huge flower. And we want to fence in. You can see we only actually need 3 sides of fencing because the brick wall counts as one of the sides. So I've got 1 side of fencing here, a long side here, and then another short side here. And we're told that the garden will be a rectangle with sides 2x and 3x. So basically, if we think about it, we have sort of 2x here, and then 3x here. Set this up. There we go. 3x. And then we've got the 2x here. You see how we're fencing in the garden? Very nice. Beautiful. And so what we want to do is we know that the area of the garden is going to be 3,000 square feet. And the question is, the manager can buy the fencing only in whole feet, and how many feet of fencing should he buy? So let's actually figure this question out. It turns out that once we set things up, we might see a quadratic. Because what is the area? So the area we know is supposed to be 3,000 square feet. And we know the area is going to be, well, 2x multiplied by 3x. So length times width. So 2x times 3x is supposed to equal 3,000. Well, that means that 6x squared has to equal 3,000. If I divide both sides by 6, I see x squared equals 500. And if I take the square root of both sides, I see positive negative square root of 500, which is actually 100 times 5. And so I see x equals positive negative square root of 100 is 10, 10 square root of 5. So there's the answer, but of course I want to know what that is numerically. You can't go to a hardware store and say I want 10 square root of 5 something. So we actually have to sort of estimate this. And so there are 2 answers, by the way. So x represents, well, either half of the length of one side or a third of the length of the other side. One's 2x, one's 3x. So the negative 10 square root of 5 doesn't make sense. So in this context, because these are lengths, so in this context, so here, in this context, we know that there's only one real answer, x equals 10 square root of 5. And the negative answer we can throw away. If we plug this into a calculator, we see this is approximately 22.4 feet. units. So how much do we need fencing? You might say, oh, we need 22.4 feet of fencing. But no, we have to go back to the original question. We need to fence all of this. Each one of these represents x. So what's the perimeter? Well, we only need the perimeter of these three sides of the rectangle because remember, this is a brick wall that's already there. So we only have to look at 2x plus 2x plus 3x, or 1, 2, 3, 4, 5, 6, 7x. So the perimeter, which is the amount of fencing that we need, the perimeter actually equals 7x. And so if we know x equals approximately 22.4 feet, then the perimeter is going to be approximately 156.8 feet. But of course, we're told that he can only buy fencing in whole feet units. And so how much is he going to buy? 157 feet is his purchase. So that's what he's going to buy. And when he has that, he'll be able to actually fence in his garden perfectly so that the area of this rectangular garden will be 3,000 square feet. And one side will be one side will be 2x and one side will be 3x, where the x is 10 square root of 5. Anyway, that is the power of looking at solving equations that are actually quadratic equations. We can use the square root if we want, and that's a neat way of doing it when the problem allows us to think square root thoughts. I'll see you soon.
So sometimes when we're solving these quadratic equations using this method, using the square roots method, we oftentimes encounter numbers that when we try to square root them, they're not perfect squares. And so we're going to handle them differently at different times. Initially, when we first learn to deal with these non-perfect squares, we're going to go ahead and use our calculator to approximate the square roots. But in the future, we're going to learn how to give our answers exactly by simplifying the radicals. So you can see in this example that when we isolate the x squared by subtracting the 6 from both sides, we end up with x squared being equal to 18. Well, remember when we talked about our perfect squares and we made a little list of those, like 1, 4, 9, 16, 25, 36, 49, 64, and so on, and 18 definitely was not on that list. So at this point, we're going to learn a little bit later on how to simplify by using some perfect square roots that we know that go into 18, and you could see that in that Dr. Berger video. He showed one for the square root of 20. But for now, what we're going to do is we are going to just go ahead and take the square root of both sides and to get x by itself, and we're going to approximate 18 using our calculator. So if we typed in the square root of 18, you can see that that ends up being approximately 4.24, and then also the negative 4.24 would also be solution. So when it's not a perfect square like that, you can, for now, use your calculator to approximate it, and usually to 2 decimal places is good. So let's go ahead and look at a couple of those problems. Let's go ahead and look at number 15. So with this one, there's a little bit more to do to get x squared alone, but first step is always to go in reverse order of operations. So I'm going to undo any adding by subtracting, and when I subtract from both sides, I end up with 2x squared on this side, and on this side I have 60. And then I'm going to undo the multiplying by 2 by dividing by 2, which is then going to leave me with just my x squared. And then on the right hand side I'm going to get 30, and since I recognize that 30 is not a perfect square, this time when I take the square root, I'm going to go to my calculator and I'm going to approximate it to the nearest hundredth, and I know there's going to be a positive and I know there's going to be a negative solution, and my calculator says it's about 5.477225575, rounded to the nearest hundredth would be 5.48. 5.48. So plus or minus 5.48. Okay, so finally we're going to look at an application. So in solving application problems by using square roots, one of the solutions may not make sense. You're trying to solve for, say, a side of a rectangle in this case. If you got a negative answer, it's really not going to make any sense. So In this question, the length of a rectangle is 5 times the width. So this is the length here, and this is the width, and you can see that the length is 5 times what the width is. The area of the rectangle is 210 square feet. So you can see over here they wrote an equation that expresses the area, because length times width is the area. So they took the length, which is right here, and they multiplied it by the width, which is here. And we know that it equals 210. Well, 5w times w is 5w squared, and that's supposed to equal 210, and this is going to give us a quadratic equation to solve. So I know that to solve it, step 1 is to isolate the w squared to get the w by itself, and I'm going to do that by dividing by 5. As you can see, they did that here, right? And then, when they did that, they got w squared is 42. 42 is not a perfect square, so they went ahead and took the square root of both sides, and when they approximated that using a calculator, they got about 6.5, and this time that negative solution really doesn't make sense, so we're just going to go with the w being 6.5, and the unit on this is in feet. And let's go ahead and take a look at an application problem of our own. And we'll take a look at number 17 just because it looks like we have a little more space there. So it says that the length of a rectangle is 4 times the width. Okay, so this is similar to the problem we just looked at. And so we could draw a rectangle, and it says that the length is 4 times the width, so we call the width w and the length 4w. And it says the area of the rectangle is 850 square inches. Find the width and round to the nearest tenth of an inch. So writing our equation would involve us multiplying the length and the width and setting it equal to the area, which is 850. And I know that the length is 4w and the width is w, so 4w times w is 4w squared. And to find out what the width is then, to get the w squared by itself, I'm going to first undo the 4 by dividing by 4. Which this time is really definitely not a perfect square. It is 212.5. And that's what w squared is. And then in order to find out what w is, we're going to take the square root. And the square root of 212.5 is approximately 14.577. And they wanted us to round it to the nearest tenth. So that would be about 14.6 inches. And that does it for our lesson today. Thanks for coming to class.